Onward to indices and answering one of the mystery questions from the migration example before. So we're going to continue our theme of be kind to the database because it is tricky and more expensive to scale. So the more you can be nice to it, the more value you can get out of it. And in particular, once you outgrow a sort of single instance database, we talked about sharding and replication. There's replica and master strategies. There's all these different things that become more complicated. So the longer you can sort of stay in this nice, simple world, the better off you'll be. We've already talked about one way to do that, which is judicious use of caching to reduce the number of database accesses. Next, we're going to talk about using indices as another way to be nice to the database, and frankly, also nice to your app. And finally, we'll talk about the N+1 query problem, which is a very common problem when you're manipulating associations. So what's an index? It's really just a hash-like data structure that speeds up access when you're searching a database table because it's essentially building a hash over some column or set of columns other than the primary key, right? Primary key lookups are instantaneous. But for example, if I say movie where rating equals PG, if I don't have some sort of an index on the ratings column, basically I need to do a table scan, right? That means I need to look at every row of the table because I might have to look at every row to find one that could possibly match. So having a reverse index, right? Something like a hash that allows me to quickly query the table in closer to O of 1 time is a big win. It's an even bigger win if you know that the attribute is uniquely valued. So if you know that, for example, you have a constraint on users that the username must be unique, defining a unique index is even better. So if indexes are so good, you might say, well, great, why don't we just put an index on every single column? And the basic answer, besides the fact that every index takes up space, right? Because now, you're taking up almost twice as much space because for every column, you're having a reverse index that can look it up by value. But it also means that whenever you update that table, any indices related to that table have to be updated as well. So it takes up space and it also increases the cost of doing a write. So what should you definitely index and why? Definitely any foreign keys. So for example, if you have a reviews table with a movie ID field, then if you want to do things like being able to find reviews associated with a particular movie, you're essentially looking up a review by its movie ID, not by its primary key. So you want an index on that column, otherwise table scan. For that matter, any column that appears in a where clause. If I say where rating equals PG and there's no index on the ratings column, then I'm doing a table scan. Columns that you sort on. If you want to be able to sort on a column, the database can actually build a sortable data structure that will speed that up considerably rather than you trying to load a bunch of table data and sort it in memory, which you should never ever do. Right? So when you're asking for a database query and you're asking for the records to be retrieved in a particular order, like sorted by the first date they logged in, it's really good to have an index on that column because it speeds up the sorting considerably. As you might guess, there is a gem that helps you with this. It's called Rails Indexes. And as your app runs, it helps you identify missing indices by looking at the queries that Active Record is generating and saying, oh, this query would have been much faster if you had an index on this column. We did a couple of micro benchmarks here. If we have 100 reviews and basically we have no indices, foreign key indices versus foreign key indices. So basically the example I gave before, if you're looking up a review by its movie ID, how much does it help to have indexed that column? And you can see that as the number of total reviews in the system increases, you get huge performance wins from having these indices in place. What's the cost of an index? Well, it takes up space, but I said it also makes the create operation more expensive because every time you change that table, all of the indices related to that table have to be updated. So how bad is that? Again, on our micro benchmark, we created an index on every single column and the reviews table, and the cost to create 1,000 entries with no indices versus with every column index was about 17% worse. If we index every single column, which is usually more than you need, right? So the bottom line is that just like in caching, err on the side of expiring too early. With indices, it's probably initially better to err on the side of over-indexing than under-indexing. The performance penalties only get big when your database gets huge, and gems will help you find places where you have unnecessary indices as well. This is a typical exam question. And when I say typical, I mean overwhelmingly likely to appear on exams because this is the sort of conceptual knowledge that indices matter. Suppose we have this setup with movie has many moviegoers through reviews. That means that you have a review. The review is tied to one movie and it's tied to one moviegoer. And somewhere in our app, we're doing a query where we have a movie and we want to get all the moviegoers associated with it. And the question is, which indices, in other words, which foreign keys on which tables should be indexed to speed up that query? So here's a picture to help us. What's the answer? Or how would we work through the answer? If we already have a movie in hand and we're trying to get all the moviegoers associated with that movie, walk through what's the sort of manual version of the query plan. The first thing we have to do is we have to figure out which reviews in here are associated with the movie. In other words, which reviews have a match for movie ID, right? So we're basically going to be searching the reviews table using movie ID as the search criterion, so we had better index that. Because if there's no index on movie ID, we have no choice but to look at every single review to see if its movie ID matches. Okay, so we have an index on movie ID, that's great. Now, given that index, we know all of the reviews that go with that movie, and now we just need to convert that into a list of who wrote each review. So we have a list of reviews in hand, and in order to get the moviegoer for each one, we need to do what? So my question is, do we need an index on moviegoer ID, or do we not need one for this query? We don't, right? Because we already have all the reviews we need. We got them by using the index on movie ID. All we need to do now is follow each one of these because it's the primary key of some moviegoer. But you don't need an index on the primary key. You can do a primary key lookup anytime you want. It's an O of 1 lookup. So in this case, the answer, if the relationships are set up in the typical way, the only foreign key ID we really need for the query is we need an index on movie ID in the reviews table, right? This is a sort of very standard problem. When you're setting up associations in Rails, if you know which queries you're going to do, right? Like if we were going in the other direction, and this is a good exercise for you to do offline, if we were going in the direction of, given a moviegoer, show me all of the movies that they have reviewed, a good question for you to go through is, which columns would require a foreign key to traverse the association in the other direction? So the indices really are there to facilitate the queries you're going to be doing, right? You can, in principle, index every column, but you really want to concentrate on the ones that are going to be used when you're actually doing your queries. And I will close this section by reminding you of something that I have said many times, and I'm going to say it one more time again, which is that all abstractions eventually leak. It's really nice to be able to say things like a movie has many reviews or a review belongs to a moviegoer. But at the end of the day, in order for those queries to run fast, you have to know how that's going to be laid out in the database. And therefore, you have to know that having indices on certain columns will make an enormous difference in practice, right? So the abstraction of has many and belongs to is great, but it's not watertight. In order to really make the abstraction function well, you do at some point have to understand something about the way the abstraction is implemented. So I think that's a good place to end our section on indices.